So, in the numerical problem, first I have to draw something. Please draw yourself also. In the question, it is written in such a manner that to anticipate the dip and the hump of any road, so it is drawn by like this one, uh, like this. There is this position is A. This, suppose a car, okay, suppose a car which moves in this direction, and this point to this point, this distance is 60 meter. Okay, let us first write to anticipate the dip and hump in the road. The driver of a car apply her brake to produce a uniform deceleration. So one point here is brake to create uniform deceleration. Okay, this is the one point is there. Next, his speed is 100 km/h at the bottom of A. Means when that car is at this position, the speed is 100 km/h, and 50 km/h at the top of this point C. So C is the top point, means this one, C. Okay, here it is 50 km/h. Clear? Which is 120 meter along the road from A. Means from this A position, the distance A to C, the distance is given as a 120 meter. Okay, means this one 60, this one is 60. If the passengers experiences a total acceleration of, it is given total acceleration 3 meter per second square. Please mute yourself, student. 3 meter per second square at point A. Hmm. And if the radius of curvature at point C is given, this point, the radius of curvature is nothing but how much it is. If it is the, suppose the center for this radius, if we consider this as a radius circle, that is the radius. So the radius, please mute yourself. The radius of curvature is 150 meter. Okay, so now what we have to calculate? We have to calculate one, the radius of curvature, radius of curvature at point A. That is, first we have to calculate, and then B, the acceleration at the inflection point B. Means the acceleration at the inflection point B. And C, we have to calculate the total acceleration at point C. So these three things we have to find out. Clear? So this is a one type of curvilinear motion numerical problem. So to find out this, first let's try to find out the velocity at point A. So we consider this one as a VA. And VA is, it is given in the question that speed is 100 kilometer per hour, right? At bottom means at A. So the velocity is how much? The velocity is 100 into 1000 by 3600. This is the meter per second, right? So it will come, how much it will come? 100 kilometer per hour, we convert it into meter per second. So how much it is? And similarly, please do the calculation and tell me. Velocity at point C is, as per question, it is given 20. B is how much it is? 50 kilometer, na? Okay. Here it is 50 into 1000 by 3600. So tell me how much? 100 into 1000 divided by 3600. How much it is?
27.7.
27.7. And this is half, na? 50. So this is 27.7 means 13.9 approx, na? Half 50. So 13.9 like that. Okay. Now we have to find the constant deceleration, because in question it is said na, that from point A to C it will be produce a constant deceleration. So right, we have to find the constant deceleration along the path. So what we have to do now, this is nothing but the velocity with respect to time derivative, and time derivative is nothing but the displacement and ds by dt. So we can write this thing as a integration of a ds is equal to v dv integration, right? This one we can write. So if it is, then from point A to, means at point A the velocity is va, at point C velocity is vc, so that is v dv is equal to a integration of ds, and s is initially it is zero displacement, after that this is equal to say s is displacement, s amount of displacement. So how much it will come now? At is equal to 1 by 2s vc square minus s square, right? So this will come, and here we know that s is the total displacement is how much? 2 into 120 na, and vc already find out, that is vc is 13.9, 13.9 square minus 27.8 square. So tell me how much it is? How much it is? 13.9 square minus 27.8 square divided by 2 into 120. How much it is?
Minus 2.41.
Minus 2.41. It means this amount deceleration is there along this path, right? Now what we have to find out, that is, as per A, radius of curvature at point A, right? So radius of curvature, if you want to find out, at point A, right? So radius of curvature means, in acceleration, previous day we already told you that two formulas there na, for acceleration. One is, remember that thing, that is, one is, if A is there, then A is nothing but a vector dv by dt tangential, and the v square by rho normal. So this one is the normal component, and this one is the tangential component na. This is the formula. So from this formula we get that an, from an we can find out this rho value. This actually we need to find, na, radius of curvature means nothing but the rho. We have to find out the rho, means the radius here. So to find out that, we have to first find out the an, right? So an is how much? How to find out the an? We already know. See, this one is the tangential acceleration, at. Okay, here you can see, when this vehicle travel from the A point to C point, so the acceleration what we find out, that is the tangential velocity, because this, you can see here that A means acceleration, total acceleration have two component, and the tangential component provide the tangential acceleration, hmm, which is along the travel direction, and another one is the perpendicular to the traveling direction. So that is, provide us the normal acceleration. Okay, so to find out the normal acceleration, what we have to do, we have to simply find out, means if a total acceleration is root over of at square plus an square, right? So we have to find out an, and an is a square minus at square, and you know the at is how much? 2.41, right? So an is, and in the question na, in the question it is said that total acceleration is 3 meter per second square at point A. So what we have to do, simply do the calculation, 3 minus 2.41 square. So now how much is an? An is how much? 3 square minus 2.41 square, root over of, how much it is? Root over of 3 square minus 2.41 square, how much it is?
1.78.
1.7 meter per second square. So this value we have to put here. Okay, so here we need to find out the rho, and rho is, v is how much? V at point A is, point A, V at point A is 27 na? So 27.7 divided by 27.7 whole square divided by 1.78. So how much it is, rho? 27.7 whole square divided by 1.78. How much it is? Could not, I could not understand, your voice actually very fluctuating. Please reply again. How much it is?
431.06.
431.06. Okay. So this is the case one, means in question it is written na, that radius of curvature at point A. So the radius of curvature at point A is 431. How much? 431.06. Okay. This is the one answer. Okay. Now condition B means B, what they written? B written the acceleration at point B, and B is where it is the in the mid. Na? See, this is point A, this is point A, this is point C, and this total distance is 120 meter, and in between there have the C. Sorry, there have the B. So as per question, find out the acceleration at point B. Okay, okay. See here at point B, as at point B, radius of curvature is infinite, right? Why? Because here you can see in this position, this is one radius of curvature, this is one radius of curvature, and this is another radius of curvature, right? Two. This is one radius of curvature. So in this position there is a infinite radius of curvature. Okay, so that's why we have to write a, we have to consider the normal component is equal to 0. Okay, and only one acceleration component is there, so that is a is at B point is nothing but the tangential, and the tangential is the deceleration, right? And that is 2.41 meter per second square, same as the point A here, right? Same as this one. Okay. Another thing you have to remember, that is, if we draw these components na, okay, let's draw these components along the curve. Suppose your curve is like this, right? So at point A is this one, and here it has shown that your acceleration is the minus 2.41. It means you travel in this direction, but your acceleration is negative. So it means what? It means your direction of tangential component of acceleration is nothing but in this direction. Okay, and the normal component, we have find out that the normal component is 1 point something na, that is positive, so that should be in this direction. And you all know that the length of the arrow is defined the magnitude of the acceleration, so the resultant that should be in this direction, and the resultant is nothing but, which is the given in the question na, 3 meter per second square. So 3 meter per second square one, they have two component an and at, and an is at point A is 1 point something, right? And what that called, at is the negative magnitude, minus 2.41, right? So it is clear, right? And see, at this point B, that is an infinite radius of curvature. So there have no normal components. Okay, and as there are no normal component, only one component is considered for finding out the acceleration, and that is minus 2.4, that's one, and that is also in the negative direction. Okay, see now case C. Case C, what they said, that the total acceleration at point C. Okay. Mm, total acceleration. Na? Okay. Okay. First for that, I think first I have to find out the normal acceleration at point, normal acceleration at point C. So the normal components is A n is equal to V square by rho, and rho is given in the question 150, na? 150 meter, and the velocity at point C is how much? We already find out half of the velocity of point A, so that is 13.9, na? 13.9 meter per second. So the A n is 13.9 square divided by 150. So it will how much? How much is it? This is point C. How much it is?
1.28.
1.28. So this is the normal component of the acceleration at point C. Now, so yeah, in the question it is said that the total acceleration is how much, right? So as you know that along this path, the tangential component is the how much? Tangential component minus 2.41. It is same na all over the path, but this an value is changed here. So an is how much? An is nothing but the 1.28 meter per second square. So the resultant is how much? The resultant should be how much? A is equal to root over of an square plus at square, and that should be 1.28 square plus 2.41 square. So that is how much? How much it is? A at C. Root over of 1.28 square plus root over of 1.28 square plus 2.41 square. No? How much it is?
2.72.
So 2.72 meter per second square is the rest. Okay. So this is the procedure to find out any normal component and the tangential component of the acceleration, and obviously the square root of there is the uh, total acceleration. Okay. So this problem is clear. Anyone have any confusion in this problem? Step by step I already discussed all the things, so anyone have any question you can ask. Is it clear? Please reply at least. Anyone have any confusion or any question you can ask, otherwise I shall continue na. So shall I continue? Student, please reply at least.
Yes, sir.
Okay, okay. So this is the one type of example for the tangential and the normal component na? Now in the previous lecture I already discussed with all of you about the radial and transverse component, right? Have you remembered that thing? in the previous lecture, na, I already discussed that one is the radial direction, radial, another one is the transverse, right? So here we already find out how to get the velocity component, that is r dot er, two unit vector, and the r theta dot e theta, right? Two things are there. And in similarly acceleration, r double dot minus r theta dot square er plus r theta double dot plus 2r dot theta dot e theta. Na? These two things we already discussed in the previous class. So these are the formula for find out the radial component and the transverse component of any velocity and acceleration. So today we shall start one numerical problem based on this. Okay. See, first of all, if okay, first draw something, then I can show you. See, problem. See, this one, this is actually means thread is there, here, and in the question it is said, suppose a rotation of a radially slotted, you can see na, that when this is the radial slot actually, and this angle is theta, and it will go in this direction, and as well as it can go in this direction, both direction. Okay, and for this position the radius is how much? This one is the radius is r. Okay, and this position is a b, and this position is a. Now in the question it is said that rotation of a radially slotted arm governed by some equation, means this is an angular movement na. So suppose it is given as 0.2 t, governed by this equation. Okay, 0.2 t and 2 t cube, where theta is the radius, in radius. Hmm? Sorry, in radian. Theta is in radian. Now the power screw in the arm engages the slider B and the control its distance from O according to R is equal to, R is also given as 0.2 plus 0.04 t square. Okay, and here R is in meter. So what we have to find out, that is the magnitude of velocity and acceleration of the slider from the, sorry, for the constant time when it is 3 seconds. Okay, for that time, means we have to find out velocity and acceleration of the slider for the instant when time is equal to 3 second. At time is equal to 3 second, we have to find out the what are the acceleration and the velocity. Okay, this is the question. So to solve this, first we have to find out what are the given things. One is theta, another one is the r. So r is 0.2 plus 0.04 t square. So r dot, if it is r is given like this na, so r at time is equal to 3, how much it is? Very simple, 0.2 plus 0.04 into 3 square. So it is how much? 0.2 plus 0.04 into 3 square. How much? At time is equal to 3, what is the radius? That we have to find out using this. So what is this? What is the value? And r dot derivative. It is in derivative 0.04 into 2t. So it is 0.08 into 3 at r dot at time is equal to 3. 3 8 24 0.24 meters. Please tell me what is this value? uh 3 3 9 4 9 36 0.36 0.56 na, 0.56 meter. And this r double dot is 0.08. So r time is equal to 3 is 0.08 meter. Okay. Sorry, one thing, double dot na, double dot means acceleration, so that should be s square, and dot means velocity, that is in second, meter per second, and that was a meter. Okay, now this is the one part. Now for the circular motion, it is given in the question that theta is 0.2 t plus how much it is? 0.02 t cube. So theta at time is equal to 3, it is shows how much time is equal to 3, 0.2 into 3 plus 0.02 into 3 cube, and theta dot means angular velocity, 0.2 plus 0 derivative of that, 0.02 into 2t, sorry, 3t square, and theta dot at time is equal to 3. 0.2 plus 0.02 into 3 into 3 square, 3 cube. And theta double dot is how much it is? 0.02 into 6t, and theta at time is equal to 3 is 0.02 into 6 into 3, 0.36 meter per second square, right? And this one is How much? 3 3 9, 3 9 27, 54, 0.74 meter per second. And this one is 3 3 9, 3 9 27, 54 আর 3 2 6. So this is 1 point. Sorry, one thing I think this is angular, na? So that should be radian per second square. That is radian per second. 1.14 it will come, na? So that is radian. So if it is in radian, we have to convert that theta is equal to 1.14 radian if it is. Then convert it into degree. How much? 1.14 into 180 by simply pi. So it will, how much it is? 1.14 into 180 degree divided by pi. How much it is? How much it is?
65.31.
66. 66. Please tell again. 60. How much it is?
65.31.
65. 65.31. It is in degree. Okay, so this amount angular movement is there. Okay, now this already means in question if it is given that the angular equation for the angular movement and the equation for the radial direction movement. So if it is there, we have to simply find out the velocity and the acceleration. Okay, now what we have to do, as from the formula from the last lecture, we know v is equal to r dot er plus r theta dot e theta. We have to simply put this value is here. So r dot is how much? R dot is 0.24, no? So v is equal to 0.24 er plus, this is the vector actually, and r is 0.56. 0.56. These all are we have done based on the, as per question it is given for t, time is equal to 3 second, na? And 0.46 into theta dot is 0.74. 0.74 e theta. So the magnitude of the velocity is nothing but root over of this portion and this portion, na? Square plus this one square. So do this one calculation yourself. Means here put this value and here put this value. 0.56 into 0.7. How much it will come? How much it will come?
0.47.
0.47. That is the velocity. Now acceleration, the formula for acceleration is which one? The formula is a r e r plus a theta e theta, na? And a r is nothing but the r dot minus, sorry, r double dot minus r theta dot square er plus a theta is, theta means r theta double dot plus 2r dot theta dot e theta. So we have to put this value again, r dot, sorry, r double dot, how much it is, r double dot, r double dot at time t 0.08, no? 0.08. minus r is 0.56 into theta dot square. Theta dot is 0.74 square er plus r is 0.56, theta double dot is theta double dot 0.36, so 0.36 square plus 2 r dot, r dot how much, 2.0.24, and the theta dot 0.74 na? So that is e theta. So this value is the a r, and this value is the a theta. So what we have to do to find out the acceleration resultant, a r square plus a theta square. How much it is? How much it is? Please tell anyone. How much it is? 0.08 minus 0.56 into 0.74 square. This is the AR. Put this value, their square, and 0.56 into 0.36 square plus 2 into 0.24 into 0.74. Their square. And root over of that
0.48.
0.48. Okay. So this is the case, means as per question when it is said na, that at time t is equal to 3 second, what should be the velocity and the acceleration of the slider. So from this calculation we can find out that at 65.3 movement of that slider, the means at time is equal to 3 seconds, the slider move this amount of angle, and there the slider the created this amount of acceleration and the velocity, whose components are, you can also find out easily their individual component na? This one and this one, means ar and the a theta. Okay, so is it clear? And for the velocity also same. uh, Another thing is there, one is this distance na? This distance, and this distance is nothing but the r, which is here it is 0.5, how much, 0.56, right? And in case of, this is the acceleration, for acceleration, for velocity what should be, for velocity here also same 65.3 degree. Distance also same, means r 0.56 meter. Now here two things are there na. One is r, so r is vr, and the one is the v theta. Okay, one is radial component, one is transverse component. And vr, you have already find out vr is how much, 0.24, and v theta is 0.56 into 0.74 na. So these two components are there. It means that slider when move in this direction, means in circular motion na, it will slotted motion. So there it will create this amount of velocity, radial velocity, this amount of transverse velocity, and this amount of radial acceleration, and this amount of transverse acceleration. So the problem is clear. Is the problem clear now? Anyone have any confusion in this problem? So today we have discussed two different types of problem na? One is the tangential and the normal formula based on numerical. One is the radial and the transverse components, and based on their the numerical problem. The two we have solved, right? So anyone have any confusion, you can ask, otherwise I end my lecture here for today. So shall I end my lecture here? Anyone have any question regarding these two problem? Okay, I shall end my lecture here. Where it is.